Okay, let's go and do a couple more. Same template. I always do that. Okay, so we're going to find the region of the volume, find the volume of the region, find the volume of the solid obtained by rotating the region, bounded by, let's say, y equals x squared, y equals 2 minus x squared, 2 minus x squared, about x equals 1. Again, we're going to set up both. Okay? So, y equals x squared. Let's try that again. That'll do. No, it's ugly. Let's try it again one more time. Yeah, that'll do. Okay, y equals 2 minus x squared. About the region x equals 1, or about x equals 1. So this point, this line may or may not be x equals 1. Let's check. So we're going to need to find when do they intersect. Okay, so looking for the points of intersection, we need 2 minus x squared equals x squared. 2 equals 2x squared, x equals plus or minus 1. So this point is on the line which we're rotating about. Okay, now I can sort of see already from here to here, this is pretty easy to see. This is easier done as a cylindrical shell. So let's set that one up first. Okay, so this integral is going to be the integral from -1 to 1. It's tempting to want to use symmetry, okay, and just be like, well, I just have to do half of it. No, it's not going to work because, look, it's not really symmetric. You're rotating this point much farther than you're rotating a point like here, okay? So symmetry isn't going to work here as much as we'd like it to, okay? All right. Next, -1 to 1, we're going to do what is our r of x? Well, let's write it out. 2 pi r of x h of x dx. Okay, r of x. Well, r of x is going to be 1 minus x. Because if I have an x here, okay, it's going to be this one. Now, I know this feels like plus x, but x here is negative. So let's think about an x here. This is this 1 minus this x. Okay, or h of x. H of x is going to be the upper minus the lower. This is going to be this, 2 minus x squared minus x squared. Okay, so we're going to get the integral -1 to 1, 2 pi, 1 minus x, 2 minus x squared minus x squared dx. Okay, all right. So let's go ahead and see to do this circular disk method. Circular disk method is a little bit trickier, a lot trickier, but we can use symmetry here. Because what we can do, I know it doesn't look symmetric by my terrible drawing, but this lower part and this upper part are symmetric. Okay, so for circular disk, I can do the integral from 0 to 2. Now, or I can do 2 times the integral 0 to 1. Okay. You may ask, well, why would I care? Well, let's see what happens. Okay. So, if we're going to do this circular disk, that means we're going to have to integrate in y, right? Okay, so y equals x squared. That's the same as x equals the square root of y. Okay, not too bad. Y equals 2 minus x squared. I guess I should have said plus or minus there. Damn it. Y equals 2 minus x squared. Then x is going to be plus or minus what? The square root of 2 minus y. Okay. So now, from here to here, that's actually, this is the positive part of x equals the square root of y. This is the negative part of x equals the square root of x equals the square root of y. Oops. So we're going to get pi times, remember we're rotating about this axis, so it's going to be r out minus r in. Looks like I'm going to have to set it up as 2 integrals anyways. So from 0 to 1, from 0 to 1, it's going to be, well, let me draw the, if I start getting overwhelmed, what do? I start resting on process. So I write out my center. My center is x equals 2, or I'm sorry, x equals 1. My inner radius is y equal, or x equals the square root of y. My outer radius is x equals negative square root of y. Okay, so I'm going to have pi times r out squared. Sorry, I don't know what happened there. R out squared is going to be, actually not, it's not even that. Terrible today and every day. From here to here, the r in is 1 minus the square root of y. The r out is going to be 1 plus the square root of y. Okay. You put all that in blue. And now I'm going to go ahead and say that's 2 of them, because it is symmetric in that this upper part is going to give me the same volume as this lower part. Okay? All right. But you can already see that hey, you know what? It was much easier to do cylindrical shell. Okay. All right. That's it for volumes of integration. I'll see you all in class.